I welcome you all to the session of engine system and performance, and the topic of our today's discussion is engine performance and its measurement. In our last few classes, we have discussed about engine control system. Specifically, our discussion was on electronic control unit and its several components, several aspects, and we had seen that for all modern engines, electronic control unit is essential, and it is because of this unit only it is possible to run engine with maximum efficiency, and that too the emission level also can be reduced. But what we have understood is that the functionality of electronic control unit depends on the input from several sensors, and all these sensors are responsible to give some feedback to electronic control unit. Receiving feedback, electronic control unit or ECU directs several parts of engine to have adequate, or I should say stoichiometry air fuel ratio to be discharged or to be drawn into the engine cylinder. Now, in line with this, today we shall try to discuss about engine performance, because essentially at the end we need to look at the performance of an engine, and we need to certify the engine performance. So, we need to measure engine efficiency, and if we need to certify engine performance, certainly we need to measure engine efficiency, and then it depends on the measurement of a few quantities. So, let us discuss today what it is all about, and then thereafter we shall discuss about measurement of a few important parameters. So, this engine performance is a relative term, and it means how well an engine is doing its job with respect to input energy. We all know by this time is that an engine can operate only after receiving some input energy in the form of fuel, I mean in the fuel itself chemical energy is stored, and at the cost of that input energy engine performs some work and we get some energy output. Now, question is to have or to establish the performance of an engine, we need to measure the output. So, how well an engine is doing its job with respect to input energy, that is essentially what it is engine performance, or sometimes we need to know that what best an engine can deliver energy or power output compared to other comparable engines. So, now the question is, whenever we talk about any particular engine or any engine, then we see that a particular engine can operate within a range of speed, and then at each and every speed within this range the power output will vary with a maximum power. So, that means an engine can operate within a range of speeds, and at each and every speed within this range power output from the engine, or the energy output I should say will vary, and there will be a maximum value of this power output. So, if we talk about an engine, we can understand that there will be a range of speeds, and at each and every speed power output will vary, but will be having a maximum power. Question is, though the maximum power will be having a there will be an unique power, that is the maximum power, but even though the power produced by the engine would be maximum, but the power that would be available at the shaft, that is the usable power. So, the ratio of power developed by a engine to the maximum usable power, that is known as load percent. So, if I try to write here the ratio of power by an engine to the maximum power, to the maximum usable power is known as load percent. So, this is what we can tell. So, this load percent will certainly is not equal to the maximum power that would be developed by the engine. So, usable power, that is the power available at the shaft, is not equal to the maximum power. So, what we can understand, though a particular engine is operating within a range of speed, and at each and every speed the power will vary, maximum power will be different, but the load percent will also different. So, certainly the performance of an engine, the performance of an engine is dependent on the relationship between the power, or among the, I should write, among the power developed, speed, specific fuel consumption, within the range of, within the useful range of speed and load. Okay. So, we are talking about engine performance. Though engine can operate within a useful range of speed, but each speed there will be a maximum power, and ratio of maximum power or ratio of power developed by the engine to the maximum usable power is the load percent. So, certainly that will vary if we try to, that means if we vary the speed, that will change, if we vary the load, that will change, if we even change this fuel supply or specific fuel consumption. So, all these things, all this speed, specific fuel consumption, all these things are interrelated essentially for the performance of the engine. So, engine performance is very important term, and if we need to predict the performance of an engine, we need to know all these quantities. So, now you know that if we go to this define engine performance parameter, typically what we have understood from our previous slide is that the engine performance depends on the speed, specific fuel consumption, and that is what you have written, and the power developed. Okay. So, even if we see that the power developed by an engine is high, but then we cannot say that at the cost of same input energy, even if we keep the speed same, but we cannot say that performance would be very high. So, we need to consider so many things, that is speed, load, specific fuel consumptions, and power developed. Now, there are a few parameters which are used to kind of measure the engine performance, and those parameters are basically speed, load, then air and fuel consumption, then finally fuel consumption rate I should say, and finally the pollution level. So, knowing all these quantities we can tell something about engine performance. So, what we need to do? We need to measure, or we need to know measurement technique of all these quantities essentially to certify, to annotate the performance of an engine. Now, question is, in addition to these 4 quantities, another one important quantity closely related to engine performance is pressure variation in the cylinder. So, this is also very important quantity to know. So, let me tell you why this is so important. If we do not know the variation of pressure, certainly it is very difficult to tell about the power developed, though we can measure speed, load, air fuel consumption rate, and to some extent I will discuss about pollution level if time permits. But the question is pressure variation inside the engine cylinder is very important to know. Probably if you try to recall, we all have studied the variation of pressure, temperature etc., inside the engine cylinder in the context of Otto and diesel cycle. We had seen that pressure is continuously varying, temperature is continuously changing in the pressure temperature of the charge or combustion gases or the air fuel mixture. So, depending on the cycle. So, if it is intake stroke, certainly it is the pressure and temperature of the charge or air fuel mixture. If it is in the power stroke, then certainly it is the pressure and temperature of the combustion gases. Now, the question is we need to measure the variation of pressure, because pressure is directly related to the power that we could calculate to measure to establish thermal efficiency of Otto and diesel cycles. Now, the pressure variation is important to know because it has some relation to know about the combustion processes. Knowing the variation of pressure, we also can measure the instantaneous rate of heat transfer, and also knowing the pressure histograms, we can tell about the knock characteristics of the engine. So, that is why this quantity is very important to know, because this quantity, if I write here, this quantity pressure is important to know the combustion process. 2 is heat transfer rate, and 3 is knock characteristic. So, all these 3 important quantities or aspects can be studied by knowing the pressure variation. So, in addition to these quantities, we also should take into account the variation of pressure inside the cylinder, and certainly if there is any specific technique or method available to know the variation of pressure inside the engine cylinder. Okay. So, now question is, if we go to the next slide, what we can say, in order to quantify the performance of engine. So, if I write here, in order to quantify the performance of an engine, right, all this speed, load, air and fuel consumption rate, pressure variation inside the cylinder, and pollution levels. All these important quantities, you know, need to be measured. So, quantities such as speed, air fuel consumption rate, pressure variation inside the cylinder, and pollution levels need to be measured. So, let us first consider the measurement of speed. So, again let me mark here what we have listed down. We have to measure speed, we have to measure load, we have to measure air and fuel consumption rate, and then we also need to measure pressure variation and pollution level. So, first let us discuss about measurement of speed of engine speed. So, probably we know by this time RPM is used to measure the speed of rotation of the shaft. Okay. So, that we know that RPM is a measure of the frequency of rotation, right. It annotates full completion of, RPM is a measure of the frequency of rotation, because we need to know the speed. So, speed of the mechanical component, that is output shaft of the engine. So, you know that if you try to recall reciprocating piston type engine, the reciprocating motion of the piston is converted to linear motion, which is available at the shaft of the engine, external shaft or output shaft of the engine. So, if we need to know the RPM of the shaft, certainly we can quantify the speed of the engine. So, RPM is a measure of frequency of the rotation, and it annotates a number of full rotation completed in 1 minute around a fixed axis, right. So, if I write here, it annotates or the number of full full rotations completed in 1 minute around a fixed axis, right. So, essentially RPM is used as a measure of the rotational speed of mechanical component like output shaft of an engine. So, if we go to the next slide, we can write that RPM is used as a measure of. So, RPM is used as a measure of the rotational measure of mechanical rotational speed, measure of rotational speed of a mechanical component like output shaft of an IC engine. Of internal combustion engine or IC engine. It is not necessarily that RPM would be used to measure rotational speed only of the output shaft of IC engine, rather any mechanical component which is turning, which is rotating. If we need to measure the rotational speed, RPM can be measured first and RPM can be counted, and that RPM is used to measure the rotational speed. Okay. So, now the question is, we know by this time, in fact we have studied from our previous classes that nowadays it is possible to have advanced sensors. So, it is possible to have all these high precision and low cost sensor because of the advancement of digital technology. So, sensors are used to sense the speed. Okay. So, if we need to measure the RPM, we need to have a few sensors. So, devices which are used to sense the speed or RPM of the mechanical component, these devices are, if I write here, typically devices used to measure rotational speed are number 1 is encoders, number 2 is photoelectric sensor, right, that is optical type, depends or works on receiving lights only. Number 3 is magnetic rotational speed sensor. Magnetic rotational sensors, this is proximity type, right. So, all these sensors or devices are used to sense the speed, essentially to predict or quantify the RPM. Okay. So, what we can do, in fact I can tell all these devices are used to measure the RPM, which is used to measure the speed or rotational speed of any mechanical component which is turning. So, if you go to the next slide, what you can understand that measurement of RPM essentially depends on the sensors, and all these sensors send data in the form of electrical pulses. That means, speed of rotation, that is mechanical motion, that mechanical motion should be converted to electrical pulses using or by these sensors. So, if you go to the next slide and if I write, right. So, sensors that we have discussed in the previous slide, sensors send data which is essentially mechanical motion in the form of electrical pulses. Okay. Electrical pulses. So, that means these RPM sensors convert mechanical motion into electrical pulses, right, with or without contact even, that means it is not necessary that sensor has to attach or sensor should be in touch with the shaft. When these sensors are taken near to a turning shaft, then only that sensor can sense the speed and can measure RPM. So, if we can measure RPM, then we can certainly measure the speed of the shaft. So, RPM sensors convert mechanical motion into electrical pulses with or without contact. It is not necessary that the sensors should be in touch with the mechanical component or mechanical components which are rotating. Now, question is, so sensor will receive some signal, mechanical motion, then will convert to electrical pulses. Finally, these pulses are sent to the, I am writing, so the resultant output signals are then fed to a digital counter totalizer, tachometer, or other controlling devices, controlling stroke monitoring device, right. So, essentially you can understand that mechanical motion should be converted into electrical pulses by the sensors or RPM sensors, and the resultant output signal will then be fed to the digital counter, then totalizer, tachometer, etc., for final monitoring or controlling or counting. So, to this end, let us first discuss about tachometer, which is used to measure RPM. So, if we go to the next slide, we can see measurement of engine speed using a photoelectric tachometer. So, if I tell something about this particular device, it is not that we always need to use photoelectric tachometer, we also can use mechanical tachometer. So, perhaps by this time that tachometers are used to measure speed of rotation or rotational speed of any mechanically moving component which is turning or which is rotating. Now, the question is mechanical this tachometer, if I write here this tachometer can be photoelectric type and it also can be mechanical type. So, mechanical tachometer, perhaps you have studied mechanical tachometer are used in several other cases, perhaps when you have done test of an internal combustion engine, perhaps you all had to measure the speed of the engine by varying. So, essentially what you had to do, we had to vary the load and we had to measure the speed essentially to obtain some performance curves of the internal combustion engine. So, during this test we all had to use tachometer to measure speed of the shaft, rotational speed of the shaft, and mechanical type tachometer utilizes the fact that the centrifugal force on the rotating mass depends on the speed of rotation. So, that is what it is. Now, question is we will be discussing about photoelectric type tachometer in today's class, and this particular type of tachometer depends on the light. Okay. So, that is what we will discuss today. or wax receiving light. Okay. So, uses wax using light. So, I should write not depends, I should write just wax. Using light. So, if we look at now the schematic depiction of this particular device which is used to measure the speed of internal combustion engine, rather shaft of the output shaft or external shaft of the engine. Let us now discuss about the procedure of measuring RPM using this device. So, what you can see from the schematic depiction is that, so if I write here now, so this is essentially engine block, and you can see that the shaft of this engine is now connected to this disc. This disc is not an ordinary disc, rather this disc is opaque. So, disc is mounted on the shaft of the engine. So, when shaft is rotating, disc also will rotate, but the special feature of this disc is opaque and has a few holes, and holes are equidistant. So, disc is opaque and has a few holes which are equidistant around the periphery. Okay. And construction is such that in one side of the disc we can see there is a light source. As I said you, this particular type works on using light, or if we need to use this particular type of tachometer to measure RPM, certainly we need a light source, because this particular sensor, RPM sensor, needs light to generate electric or electrical pulses. So, this opaque device, opaque disc is rotating continuously because disc is connected to the shaft. The disc has a few holes around the periphery and holes are equidistant, and in one side of the disc there is a light source, and on the other side of the disc there is a light sensor. So, this light source and light sensor, and also the disc arrangement in such that light source hole, that is center of the hole, and light sensor, they are in line with each other. So, construction wise disc is fabricated along with all the equidistant holes in such a way that light source, center of the hole or holes, and the light sensor, all these three are in line with each other. So, you know that when the disc is rotating, then hole and that opaque part will appear alternatively between this light source and light sensor. Now, when hole is appearing and hole center and light source and light sensor, they are in line. So, light will pass on to the sensor through the holes, and when that sensor is getting light, it will generate electric or electrical pulses. So, now the frequency of that so we know the number of holes, and if we need to measure the speed of the shaft, then there is a relation. So, if we try to write here, so that is what is the operational principle or procedure of measuring RPM using this particular type of tachometer. Okay. So, what is the situation? Only when hole will appear in between light source and light sensor, the light will pass on to the sensors through the holes, but when opaque part is appearing in between, because it is continuously rotating, no light will pass and sensor will not be generating any electrical pulse. So, if I write here that if we frequency, so when light passes light passes onto the sensor through hole, electrical pulse is generated. When opaque part opaque portion or part comes in between light source and light sensor, no pulse is generated. Okay. So, using this, what we can say, the frequency of the pulses, now frequency of the pulses generated because of this particular phenomenon, frequency of these pulses depends upon the number of holes and speed of rotation of the disc. Using the relation, that is speed n equal to f upon h. So, this h is number of holes, f is frequency of pulses. So, if we can somehow, because we know the number of holes, we can count the frequency of pulses being produced by the light sensor, then certainly we can use this relation to calculate the RPM of the disc, which is equal to the RPM of the shaft itself, right. So, if we write the statement, so number of these pulses, so we need to know the frequency of the pulses, that is number of pulses we need to measure. We can also measure the time. So, number of these pulses, if I write here, the number of these electric pulses are number of these pulses is measured with the help of electric counter, which is a measure of the speed, which is a measure of the speed of shaft following this relation, right. So, that means we can use this particular type of tachometer to measure the speed by calculating the number of pulses which can be measured using electric counter. As I said you, with the advent of digital technologies, it is possible to measure so many things with low cost and high precision sensors. So, to summarize our today's discussion, we had talked about engine performance and we had seen why it is so important. To quantify engine performance, we need to measure a few quantities or a few parameters, and we had seen what are those parameters, and then we had discussed about measurement of an important parameter, that is measurement of engine speed. We had discussed about the tachometer which is used to measure engine speed for modern engines. So, with this I stop here today, and we shall continue our discussion on the measurement of several other parameters in the next class. Thank you.